questions 11 through 20 on the 2004 grade 9 Pascal math contest. In the diagram, square ABCD has a side length of 4. What is the total area of the shaded regions? So this is 4, and this is 4. Now what's interesting about this shape is that when you look at it, they don't really give us any information, right? They just give us a bunch of right angles. But when you draw these diagonals, for example, this one right here, it cuts that rectangle in half. So for example, if this has, let's say, an area of W, this is also going to be W. In a very similar way, if this is, let's say, X, this is also X, the area. And similarly, if that's Y, that's Y. And finally, if that's Z, that is Z. The areas will all be equal like that, because when you draw a diagonal of a rectangle, you're basically cutting the area in half. So the total area of this entire square is 4 times 4. And in terms of our letters, that is 2W plus 2X plus 2Y plus 2Z. So 4 times 4 is 16. Factor out the 2 and you get W plus X plus Y plus Z. Divide through and you get 8 for W plus X plus Y plus Z. And that is basically the area of the shaded region. And that is what they're asking us to figure out. What is the total area of the shaded regions? So the answer is 8. And therefore number 11 is B. In the diagram, 2 equal armed balances are shown. How many squares would it take to balance one circle? So in the first one here, if I were to draw a equation, it would be 3 triangles are equal to 5 circles. Okay, I shade in the circle to ensure that you don't mistake that for a 0. And in the second, I guess, balance, you've got 1 triangle is equal to 2 squares plus 1 circle. All right? And that's all the information they give us. Now, they want you to figure out how many squares are equal to 1 circle. Okay? So I'll call this equation 1. I'll call this equation 2. We are only considering a final equation involving a square and a circle. So that means that these triangles we want to get rid of somehow. And that shouldn't be that difficult to do. If I just take the first equation and subtract from it 3 times the second equation, I should be able to get rid of those triangles. So let's see, what does that give me? 3 triangles minus 3 triangles. And on the right side it would be 5 circles minus 3 times this guy. So 6 squares minus 3 circles. All right, this side here becomes 0. This becomes 2 circles is minus 6 squares. Bring the minus 6 squares over. You get 6 squares is equal to 2 circles. And then divide through by 2, and you get 1 circle is equal to 3 squares. So there you go. That's what they wanted. And therefore, number 12, the answer is C. Nadia starts at S and walks at a steady pace once around the perimeter of a square park. Which graph best represents her distance from S as time passes? So S is right here. All right. Now what's interesting is that initially she starts walking this way, right? And then she walks, I guess, a little bit southwest. And then the exact same way, but coming back this time. Now, they have these 5 graphs, right? And they're very similar. They didn't actually make these graphs that much different. But there's just one way, or one really key thing that you look at to differentiate these 5. And that is this point right here. That point right there. At that point, she is the farthest she can possibly be from S. Correct? I hope you agree with me. So if she starts at S right there, that point is the farthest she can possibly be. So this graph, or these graphs, one of them, the correct one, has to represent that. That means there has to be a singular point that is the absolute farthest. Because every other point on here, whether you're going that or that direction, this direction, every other point, she is closer to S than that point right there. Okay? So let's take that into consideration. Which one of these graphs has one singular point that is the farthest? Let's take a look. How about A? A has a whole bunch of points that they've got representing the farthest. Well, that doesn't make any sense. B has 2 points that they are calling the farthest from S. Well, that's not our case. C, there you go. The absolute top represents the farthest, and that's this point. Let's just look at D and E. D, they've got 3 points that are tied for being candidates for the farthest from S, and E has 2 points. So by process of elimination and also by just concentrating on that one point, the answer is C for number 13. How many unshaded squares are in the 10th figure of this pattern? Right, so this is the first one, this is the second one, this is the third one, and then eventually you're going to get to the 10th one. So let's figure out what kind of a pattern they have here. So the first one, the total number of squares is 3 times 3, right? And then the shaded is just 1 squared. And that gives me 9 minus 1, which is 8, for unshaded. Okay? And in the second one, we can figure out that the total is this time 4 squared. And we're going to subtract from it 2 squared because 2 squared represents the number of shaded. And that looks like 16 minus 4, which is 12. The third one, the total is 5 squared. And the number of shaded would be 3 squared. So you see, these numbers are actually not that important below the line. It's these guys that have a very clear pattern. So the 10th, if you follow the same one, it would be, well, you're minusing, looks like the same number. So that's going to be minus 10 squared. And the total, it looks like it's always 2 more. So if it's 3, it's 5. If it's 2, it's 4, like that. So that means the total is 12 squared. And therefore, if you do the math, it's 144 minus 100. And therefore, for the 10th figure of this pattern, the number of unshaded squares is 44. So number 14, the answer is D. In the Pascal family, each child has at least 2 brothers and at least 1 sister. What is the smallest possible number of children in this family? All right, let's just look at the answer choices and go from there. 3. Let's say there's only 3 children in the family. And let's see if the criteria can be met. We've got 2 brothers, 1 sister. Perhaps, I don't know. Each child has at least 2 brothers. All right, well, the sister does indeed have 2 brothers. How about the brothers? Do they have at least 2 brothers? Well, no. That doesn't work, right? No problem. So 3's out. Let's try 4 kids. Let's give it an equal brother and sister combination. Each child has at least 2 brothers. Well, this girl, she does indeed have 2 brothers. But this boy doesn't have 2 brothers. He has only 1 brother. So that makes me think that you're going to have 3 brothers for this to work. All right, no problem. Let's put in an additional brother and see if this works. This girl has 2 brothers. Great. This boy has 2 brothers. Perfect. But this girl, you have to have at least one sister, and she doesn't have any sisters. All right, no problem. 4's out. Let's try 5 kids. So let's try 2 girls and 3 boys. This girl has to have at least 2 brothers. She does. And she has to have at least 1 sister. She does. And now let's look at the boys. This boy has to have at least 2 brothers. He does. And he has to have at least 1 sister, which he does. So there you go. 5 is the smallest possible number of children in this family. So 15, the answer is C. If a squared plus 3b is equal to 33, where a and b are positive integers, what is the value of a times b? A squared plus 3b is equal to 33. And that's it. They don't give us anything else. Okay, so that basically means this is going to be inspection. All right, so they give you a clue, of course, that a and b are positive integers. All right, let's just make a table and see what kind of values we get. And let's see here, what do you want to start with, A or B? Let's start with B. B is a little bit easier, right? Because it's not a square. So let's say positive integers, the lowest possible number is 1. If B is 1, A looks like it's going to be the square root of 30. Well, that's no good, right? Because A has to be an integer. All right, let's keep going. For 2, looks like square root of 27. 3, square root of 24. 4, square root of 21. Still not getting a integer. 5, square root of 18. 6, square root of 15 for A. 7, square root of 12. 8, square root of 9. Okay, finally get a integer. So this is a solution. A 3 and B equal to 8. So they want you to find the value of A times B. All right, no problem. That's 3 times 8. And that is 24. So number 16, the answer is B. The value of 0.1 repeat plus 0.12 repeat plus 0.123 repeat. Okay, so what I like to do in these kinds of questions is sort of write them out in the same sort of level, one on top of the other like that, and that way I could match them up. So you all know what that symbol means, right? The symbol, it just means repeat, that those 3 numbers or those 2 numbers, whatever the numbers that the symbol is above, will keep repeating. So 1, 2, 3 is going to be 1, 2, 3, 1, 2, 3, dot, dot, dot. Just keeps on going. Now you're adding all 3 of these, right? Okay, let's start adding, starting with that column. 1 plus 2 plus 3 is 6. Then 1 plus 1 plus 2 is 4. 1 plus 2 plus 1 is 4. Then we've got 5, 5, and 3. And this is 0, of course. All right, let's see the answer choices. Oh, this is dot, dot, dot. Don't forget that. All right, which answer choice matches this? 3, 5, 5, 4, 4, 6. This one right here. Correct? Because I just wrote the first 6 digits after the decimal point. This will obviously continue because the pattern is the same. So 17, the answer is D. The symbol ABCD equals AD minus BC. If x minus 1, 2, 3, and negative 5 are equal to 9, what is the value of x? All right, so they've given you the definition of that symbol, and let's just apply that to that box. So that would mean x minus 1 times negative 5 minus 2 times 3. And that is all equal to 9. So this means minus 5x plus 5 minus 6 is equal to 9. Minus 5x minus 1 is equal to 9. Minus 5x is equal to 10. And therefore x is equal to negative 2. So number 18, the answer is C. Raffaello's tree grows according to the following rule. After a branch has been growing for 2 weeks, it produces a new branch every week, while the original branch continues to grow. The tree has 5 branches after 5 weeks, as shown. How many branches including the main branch, will the tree have at the end of 8 weeks? So they've helped us out by giving us the situation up until 5 weeks, right? This basically describes 5 weeks of growth for this tree. And they want you to figure out what it looks like at 8 weeks. All right, let's do that. I think I might need a lot of space here. So let's see here. And I'll make a little table here. The number of weeks and the number of branches. So weeks and branches like this. All right, here we go. Let's see what we get. So initially, when there's nothing, we have nothing. And that's why I drew that little ground there. But eventually we got 1 week, and whenever there's a week, I'll draw a little circle like this or a dot to kind of represent. So I've got 1 week has passed, and I've just got this one lone branch. Another week goes by, and still just one branch. Now the action begins. Remember, after every 2 weeks, a new branch comes. So I'll just draw it on the side like that. So 3 weeks have passed. And since 3 weeks have passed, we now have 2 branches, correct? This was week 1, this was week 2, and this was week 3, but then after week 3, we've got an additional branch there. All right, so I hope that makes sense. Let's keep going. And remember, the first 5 weeks they already gave us. But I'm just doing it again because I want you to understand. You probably already do, but just in case. All right, we got another week, week 4. But week 4, remember, this guy keeps growing. Don't forget about him. And every week, an additional branch comes. So now how many branches do we have? Well, week 4, we have 1, 2, 3. Right? 1 here, 2 there, and 3 there. Don't count the number of individual sticks. That's not what they want. They just want the branches. Okay, so far so good. Now we get into the 5th week. So this is 5th week. We're going to have 1 more growth here. But remember, 2 weeks have passed for that guy, so he's got another one. Another growth there, and another growth there. So we got 1, 2, 3, 4, 5 this time. And this is what they gave us here, right? 1, 2, 3, 4, and 5. They have 5 also. So far I'm doing it correctly. They just draw it in a little bit different way, but how you draw it won't make a difference as long as you understand it. So we've got to go 6 weeks, 7 weeks, and 8 weeks. So this is my goal to get to that number. All right, I don't know what it is. Let's keep going. 6 weeks, okay, that keeps going up. This guy goes 1 more, and this guy goes 1 more, but 1 week has passed, so he's got to grow another branch. Very similarly, he grows 1 more, but he's got to grow another branch like that. He grows another branch, or not another branch, sorry, another, extension, and this one grows. All right, so just be careful with that. So now how do we have 1, 2, 3, 4, 5, 6, 7, 8. 6 weeks, it's 8. Okay, I'm going to start using a different color now. Might get a little confusing otherwise. Now I've got my 7th week. All right, let's take it easy here. That grows 1, correct? That grows 1, but 2 weeks have passed for this branch, so he's got to grow 1. That grows 1, that grows 1. This grows 1, this grows 1, and this grows. And then that grows that way. 2 weeks have passed, so he's got to branch out a little bit, and this grows 1, that grows 1. All right, so how many do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. Now, I just want to emphasize I don't want to cause confusion here. I shouldn't have drawn it like that. That causes a little bit of confusion. it makes you think that those are two branches. They're actually not. So I'm going to just extend it down. So little things like that can kind of get you a little tripped up, right? It's one branch, it's not two. When you twist it like that, it makes you think that it's another branch. All right, we're almost done here. One more, 8. All right. Okay, this one goes one more. This one grows one more. This one grows one more, but another branch there. One more for this guy, but another branch. One more for this guy, and one more for this guy. This one grows one more, but don't forget, we've got to branch out because it's been more than 2 weeks. This one grows one more. This one grows, and we got another one there. This one grows one more. That one grows one more. That one grows one. This one grows one more. It's been 2 weeks, so that one grows one. That one grows, and a new one. All right? Okay, let's count these up. So we got one big one, correct? 2, 3, 4, 5, okay? 6, 7, 8, and let's see, 9, 10, 11, 12, 13, and then now we got 14, 15, 16, 17, 18, 19, 20, and 21. All right. So it's a little bit of a time consumer, I think, and a little confusing, especially if you draw it in a slightly inappropriate way, like I did. But it's okay, you can get the final answer. And therefore, number 19 is A. At the beginning of the game Clock 7, the arrow points to one of the 7 numbers. On each turn, the arrow is rotated clockwise by the number of spaces indicated by the arrow at the beginning of the turn. For example, if Clock 7 starts with the arrow pointing at 4, then on the first turn the arrow is rotated clockwise 4 spaces so that it now points at 1. The arrow will then move 1 space to the next turn, and so on. If the arrow points at 6 after the 21st turn, at which number did the arrow point after the first turn? So, I have been given the task of figuring out the first turn after they've given me the 21st turn. So I'll write out all the turns from 21 down to 1. So what they tell me is that on the 21st turn, the arrow points at a 6, okay, after the 21st turn. So arrow position, I'll write in orange right here. And they want me to figure out this number right here after the first position, or the first turn, a better way of saying it. What number is the arrow pointing at? Okay, so it's 6 here, right? So where will it be on the 20th position? Well, I have no idea, to be honest, because they don't really tell me. Because something has to be added to some number in order to get to 6. And I don't know what that is. So in this question, very interesting, what you have to actually do is go forward. Because you can't go backward, don't have enough information. So I got to go forward and see if going forward gives me any kind of a pattern or not. All right, so I'll go forward till, I don't know, I have no idea actually. It's one of those experimental questions. All right, what I do know, the only thing I know, is that after 21st turn, it's at 6. Okay, now what does that mean? That means that because you're here, you've now got to move 6 times to get to the next number. Okay, 1, 2, 3, 4, 5, 6. All right. So that means the 22nd, after the 22nd turn, I'm here. I'm at 5. All right. Let's continue this process, see if we get some sort of a pattern. I'm at 5, I've got to move 5 now. So I'm here, I've got to move 5. So 1, 2, 3, 4, 5. Now I'm at 3. That means that after the 23rd turn, I'm at 3. Okay, let's do this again. I'm at 3, I've got to move now 3, right? Because I moved the number of times that the number indicates. The number is 3, so I've got to move 3 times. 1, 2, 3. Oh, I'm back at 6 again. All right, let's just keep going here. I've got to move how many times now? Since I'm at 6, I've got to move 6 times. So 1, 2, 3, 4, 5, 6. Oh, I'm back at 5. All right, so I think I already see the pattern. I'm just going to keep going here. I'm at 5 now. I've got to move 5 times. 1, 2, 3, 4, 5. Oh, I'm back at 3. So this pattern just keeps repeating. 6, 5, 3, 6, 5, 3, and so on. I got it. Okay. So if I go backwards, it's going to be the exact same thing. This will be 3, 5, 6, 3, 5, 6, and so on. 3, 5, 6, 3, 5, 6, 3, 5, 6, 3, 5, 6, 3, and 5. So after the first turn, the number or the arrow points at the number 5. So number 20, the answer is C.